Okay, so section 10, calculate the number of molecules. This is going to be our final, or formula units, depending on what it is, our final unit. So since we're dealing with mass, we know we're going to have to calculate molar mass at some point. So I'm just going to go ahead and get that out of the way. 5 C's, 5 H's, 1 N. So 5 times 12.01, 5 times 1.01, and then 1401. Put all that in my calculator. I get 79.11 grams per mole, so that's the molar mass. So I'm going to start out with grams of this substance. I'm going to convert to moles. And then from here, 1 mole of C5H5N is equivalent to 6.022 times 10 to the 23 molecules of this substance. Now don't be lazy and stop writing, the unit and the substance. That's a requirement of dimensional analysis. And multiply all the top numbers, this times this, divided by 79.11. We need two significant figures, so 6.4 times 10 to the 19 molecules of C5H5N. At this point, if you see kilograms, you know they need to go to grams first, and so on. So I'm going to go ahead and jump on to section 11, do one of those examples. Here we need to calculate the mass, and we're going to start out with molecules. So let's go ahead and start with this, which I gave you the formula of fluorine. F2, it's a diatomic gas. So we need to convert to moles first. 1 mole of F2 is equivalent to 6.022 times 10 to the 23 molecules of F2. 1 mole of F2 is equivalent to the mass in grams of F2. Now when you calculate the mass in grams, you need to do 2 fluorine atoms. So 2 times 19 is 38 grams per mole. 38.00 grams per mole. You can see that all my units cancel. Moles and moles, molecules, molecules. And then I type in 8.39, second E 23, times 38 divided by 6.022, second E 23. I need 3 significant figures, and so in my calculator I get 52.9, and this is grams of F2. Okay, molecules, make sure you get the correct formula for nitric acid. Let's go into number 12. Now, calculate the mass of each of the following gases at STP. We know the conversion factor for anything at STP is 1 mole is equal to 22.4 liters. So we're going to use that to go from volume, in this case, to mass. Okay, so liters of NH3 on the bottom, 1 mole of NH3 on the top. We know it's equivalent to 22.4 liters. That's where we get that conversion factor. Now that we're in moles, 1 mole of NH3, we can convert to grams of NH3. So we need to go over here and do this on the side. We get 1401, 3 times 1.01, 1704 is the mass. Our units cancel, liters, moles, 5.7 times 17.04 divided by 22.4. We get 2 significant figures, so 4.3 grams of NH3 is what that would be equivalent to.